Hi, I would like to thank World Board of Groupcraft 3 to organize this talk series. My talk will be on reciprocity in Hecke group. So this is a joint work with my supervisor, Dr. Krishnendu Gongopadhyay. An element G in a group G is called reciprocal if there exists H in G such that G inverse equals to H inverse, and G is called strongly reciprocal if H is an involution. And if equivalently, an element G is strongly reciprocal if it is a product of two involutions. So the reciprocal elements are also known as reversible elements and real elements in the literature. We'll call the conjugating element H as a reciprocator of G. The reciprocator is also known as reverser and reversing symmetry. The classification for the reciprocal elements of for the group brings new set of ideas in the geometry. H to be a upper half plane model for hyperbolic two space. Then the orientation preserving isometry group for H2 is PSL2R. The discrete subgroup of PSL2R is called Fuchsian groups. The action of PSL2R on H2 is defined by the Mobius maps. So this is our first result for the reciprocity in Fuchsian group. What is that? A gamma be let gamma be a Fuchsian group, then an element is in that Fuchsian group is reciprocal if and only it is strong reciprocal. Further, the reciprocators for any reciprocal elements are all involutions. The only possible reciprocal elements in gamma are either hyperbolic elements or involutions. So here we get one-on-one corresponding between the conjugacy classes of the maximal infinite dihedral subgroups and the strong primitive reciprocal classes in the Fuchsian groups. Let A be a hyperbolic element in PSL2R, then the matrix tilde is a lift of A in SL2R. Theta A is defined as it's called fixed point ratio, and it is defined as B minus C by A minus D, where A not equal to D. Infinity when B not equal to C and A equal to D. When both equality will hold, then it will be 1. So when A not equal to D, then the fixed point ratio is it can be seen as a function of two fixed points of A. So that's why the theta A will be invariant for a cyclic group generated by A. So, and let A be a hyperbolic element in PSL2R, then and such that theta is less than 1, then A is a reciprocal element with a reciprocator phi, and for every hyperbolic element we know that in PSL2R it is a strongly reciprocal element. But what are the reciprocators? So here phi is the reciprocator and other reciprocator is phi into A. The Hecke group gamma p is a Fuchsian group which is generated by the two function, that is iota z goes to -1 by z and alpha z goes to z plus 2 cos pi by p, where p greater than equal to 3. Geometrically, the Hecke group can be identified as a z2 star zp, where iota gamma p is an p order element. Example, for p equal to 3, Hecke group is a well-known modular group PSL2Z. The classification of the reciprocal classes for the modular group is well known and mentioned in that O'Farrell and Yancey's book. The reciprocal classes for the Hecke group, the odd cases where p is odd, it is similar. It's very similar to the classification of the modular group. So here is the corollary for the lemma. for the previous lemma that if A is conjugate to B by iota in PSL2R, then theta A equals to minus theta B, where in theta A not equal to 1. So here if A is conjugate to B by A is conjugate to A inverse by iota, then A is conjugate to a theta equal to minus theta A. So that's why theta A is equals to 0. That means B equal to C. So this implies that A is a symmetric matrix. It has a symmetric matrix in PSL2R. So let A be a hyperbolic element PSL2R, then the tilde A to the power K, the tilde A is a lift of A in SL2R, which is symmetric if and only, and tilde is a symmetry with a non-zero integer K. Let G be a PSL2 G be a element of PSL2R, then a symmetric matrix, if it is represented by G tilde, the lift of G in SL2R, which is symmetric matrix, and then then iota will fix the the fixed points of G is invariant under iota. So let a hyperbolic element G in gamma P such that G is conjugate to an element in gamma P such that it has a symmetric matrix representation in SL2R. Then G is reciprocal. So here is the next theorem that the gamma P in the Hecke group where P is odd, then G is reciprocal if G is either involution or conjugate to a hyperbolic element which has symmetric matrix representation in SL2R. So for the even case, we have two type of involution up to conjugacy. So for that, the conjugating the reciprocators are also conjugate to either iota or gamma P to the power m. So first we will calculate the gamma. What is the gamma P to the power m? So for that, we take A as a lift of gamma P and calculate A to the power K. And the next lemma, we calculate the gamma P to the power m, which is the lift of gamma P to the power m, which is given by that matrix. So any reciprocal hyperbolic elements in gamma P has a reciprocator conjugate to either iota or gamma P product. So A be a hyperbolic element with theta equals to cos pi by P, then then A is a reciprocal element with a reciprocator gamma P to the power m. So there is the next theorem that if let gamma P be a Hecke group for P greater than equal to 3, then the G is reciprocal. Then G is reciprocal if and only if G is either an involution or conjugate to a hyperbolic element which has fixed point ratio either 0, 1 or cos pi. This is our final result. And here is some reference. Thank you.